put this in here. So this, there we go. Problem number 2 says that a satellite moving in space with a linear velocity of 470 meters per second has a mass of 100 kilograms, and it fires rockets to create impulses on the graph. And it says the forces are applied along the direction of motion. What is the satellite's velocity after the time of 7 seconds? Okay. So here's an interesting thing. So let's first figure out what the initial momentum is. So the initial momentum is equal to the mass times the initial velocity. The mass of the rocket is 100 kilograms times the velocity of the rocket, 470 meters per second, which is going to be 470,000, I think, right? Does that seem right? Let me make sure that I'm doing everything right. So remember that force is acting over time. So that is the momentum. And then another way that you can calculate momentum is, shoot, I keep hitting the wrong thing. The other way that you can calculate momentum is the force.
Mr. Adams.
Yes.
3 zeros, not 4.
3 zeros. I thought I was wrong. I'm using some new software, so I'm having a little difficulty bouncing back and forth. 47000. All right. I said I think. So also remember that your initial momentum. So this is the momentum initially. And then it says the satellite fires rockets, and it has these impulses. So we can increase the momentum. So what is this? Well, the force looks like it's 8,000 newtons, right? But it's being fired over 1 second, right? From 3 to 4 is 1 second. So that momentum is 8,000 newtons times 1 second, or 8,000 newton seconds, or 8,000, positive by the way, kilograms meters per second. Now over here, we apply the force. Remember that a negative force means it's going to oppose it. But that goes for 1, 2, 3 seconds. So this momentum here, we'll call this momentum 2, I guess. And then we'll call this momentum 3 is the force. And let me write this down over here. Remember, momentum, or the change in momentum, can be the force times delta t, or momentum could be the mass times the velocity. So I've got negative 8,000 times 3 seconds. 8,000 newtons. So that's negative 24. Right? I don't know why I put that in parentheses. So we need to figure out the sum of this, right? This is negative 24 Newton seconds, which, by the way, is the same as kilogram meters per second. So I have 40. We got to figure out what the final velocity is, right? So that means I need to figure out what the final momentum is. So I start off with 47,000, and then I add 8,000, because that's what I changed my momentum, and then I have to subtract 24,000. I hope that's correct. So I got my little handy dandy calculator. I've got 47,000 minus 8,000. No, it's plus 8,000. Minus 24,000. So my final momentum, after all these changes, is equal to 31,000 kilogram meters per second. So remember, if I do a little algebra, isn't the momentum divided by the mass equal to the velocity? So if I want to know the final velocity, I take the final momentum, which is 31,000, and I divide that by the mass of the rocket, which is 400. Oh, not 400, it's 1,000. A lot of numbers here. Which is what? 31 meters per second? Now let's hope and pray that's one of the solutions, is it?
No, I think the mass is 100.
Oh, well then it'd be 310. I know. Well, I'm human.
I didn't think you were, so now I know.